Thank you, Alcina. Thank you, General Chandele, for having given me this opportunity to be here and speak my small wisdom, whatever I can share. So in the next about 7-8 minutes, I'll be focusing on cyber resilience. Cyber resilience, and I'll touch upon, make it peculiar to the drone technology. Cyber resilience is the capacity of an organization in general to prevent, identify, and recover from a cyber threat. So anytime a cyber threat happens, it should be able to withstand that attack. Not only that, it should be able to continue functioning without the functioning getting affected. So that's basically the gist of cyber resilience, what exactly it is. Now the theme of the conference is Strategic Electronics Roadmap for 2047. 2047 is about 23 years away from now. 23 years, is it too far or is it too near? Today, I feel and I see that future is approaching us at a very fast rate. Unlike in 70s, 80s, when we used to say that future is about 50 years ahead, kya hoga, us samay kya hoga. Today, future is approaching us at a very, very fast rate. We do not know what will happen in next 5 years, how the technology or how any of the dynamics of technology vectors will affect into the relations between countries. Today, this relationship between the countries, the diplomacy, the technology dependence on each other, it's absolutely very important. So while we have been discussing over maybe last 2 decades, not just about drones, the threat vectors, we have been focusing on, if we get peculiar to the drones, we generally speak, when we speak of the cyber threat vectors, we speak of spoofing, we speak of signal jamming, we speak of malware, we speak of DOS attacks, DDoS attacks, we speak of MITM, wireless attacks, we speak of tampering, repudiation, elevation of privileges, etc. So this is a set of threat vectors on which we have built upon our solutions, our resolves, and there is a business industry to it which is able to offer their products to these. Now, I'm not saying that these technology vectors or threat vectors, whatever I have mentioned about, this is all about it. With the impending times ahead, whether it is AI, whether it is quantum, whether it is any kind of new generation technology, which I'll just touch upon with the mention, these technologies will get overwhelmingly minuscule. Although the threat will remain the same, but we'll have more bigger threats than this, and more bigger will be more difficult. So if we have been fighting for last 10 years, peculiar to drones, these threat vectors, whatever I mentioned, with the new age technologies, we are bound to get more vulnerable to all these. So I'll list about 20 plus technologies as on date, and I'm not going to discuss any one of them. You just have to make up and relate what is the Indian footprint in that. What is the Indian footprint, not as users, from point of view of design, developing, and any kind of influence that we have been able to impart into that. So operating systems, mobile operating systems, cryptography, encryption, hashing. Encryption basically moves around the well-known encryption algorithms, AES, RSA, DES, 3DES, Blowfish. Hashing, again, we come to MD5, SHA3, SHA254, SHA512, any Indian footprint. These are all NIST qualified cryptographic algorithms. Semiconductors, processors. Now, semiconductors and processors, we have got a national semiconductor mission, but our mission is 28 nm by 2026. The world currently is fighting upon 2 nm, 3 nm, and we have a vision of 28 nm. So we have to go actually full throttle on many things. Storage. Whether it is RAM, whether it is hard disk, whether it is SSDs, whether it is HDD, whether it is cloud, whether it is anything. Then quantum technology. We see each and every product that is in the market relative to the NIST standards, whether it is the post-quantum cryptography standards in terms of dilithium, in terms of Sphinx, in terms of isogeny, or in terms of Kyber crystal. We have got that standard. We do not have currently any of our own standards on which we build our own products, which are indigenous, purely indigenous. Rare earth metal processing, long way to go. Cloud infrastructure, role in ICANN, Internet Cooperation of Assigned Names and Numbers. Do we have a role in ICANN? ICANN is basically the boss of Internet, although it has got a neutral role supposedly, but again, it is relative to one particular country, one particular state. Antivirus companies, GPS dependence. We have got Navic today. For last 2-3 years, we have been discussing Navic. But again, Navic, it will take time to basically intrude and reach our mobile operating systems and any kind of network time protocols that we may follow. Supercomputers, AR, VR, ER, MR, AI, GPT models, AI, GPT models. So if you have heard anything of indigenous GPT, you have to go deep down what exactly is indigenous about it. We have customized pre-trained models. Pre-trained, whether it is BERT, whether it is BART, whether it is Robot, whether it is Llama, whether it is anything of GPT-3, GPT-4, we have customized it. The bias, the black box, that remains. And we have got currently no capability to audit a black box. So if there is any hidden prompt, we absolutely take it as a vulnerable thing. Embedded operating systems, 3D printing. So these are about 20 plus technologies that I've just mentioned, and you have to see or relate yourself where, how are we connecting with our footprints. Now I'll come to the resolves. So this is all there. So how do we resolve, or where do we go ahead? I'll not discuss about the conventional, again, the well-known security solutions like UTM, firewall, IDS, IPS, VPN, multi-factor authentication, PKI, SSL, sandboxing. No, this is all exactly, there is nothing that I am denying the importance of these solutions, but we have to move forward. 2047 is the roadmap, so we have to start building our processes and thoughts to align with the futuristic threats that may come on. So if we see post-quantum cryptography, well, I have already discussed what kind of algorithms are currently available. What are we doing? RRI, somebody might have heard about this 2 weeks back. Raman Research Institute had come up with this Lagarde-Garg inequality randomness about 2 weeks back, based in Bangalore. Now, they have come up with something very special. Now, they have been able to harness randomness about this LGI algorithm, which was made in 1983. So, it is not like they have done something absolutely niche, but they have improved upon the speeds. They have generated 9 lakh keys out of the new algorithm that they have made. That algorithm is able to generate 4,000 bits per second. That's a huge speed at a world when we compare with other works that have been done. So we have to make this, we have to look forward to get this into a product so that it reaches us somewhere. Otherwise, this remains as a appreciation inside that particular journal paper. Then blockchain technologies. Blockchain is a strong technology, but it is again dependent on multiple encryption and hashing algorithms, which are not currently ours. So we have to move into post-quantum blockchains. Post-quantum blockchains, again, we have to have our own standards rather than relying on a particular country's trust. Today, digitization is penetration everywhere. So when it is penetrating everywhere, so we have to be doubly sure that this does not make us vulnerable few years later. So in case we are happy adopting these standards, we have to be doubly ensure ourselves that today, in case the relations with country A, B, C, D are good, it may not be the same after 10 years. Then we have got homomorphic encryptions. Homomorphic encryption, again, something coming up for last about 10 years. It's happening, and it is now coming up in form of a product. You will be able to process data on an encrypted matter, on encrypted data. You need not decrypt it. So on an encrypted data, you will be able to process it. So we have to work on these kind of technologies. Then, if you have heard of Brown corpus is basically 1960s it was made, and now this is the foundation for today's NLP models. Brown corpus basically consists of all the vocabulary of English words, their vectorization, lemmatization, their normalization, etc. Analogically to that, we have to come up with something known as, which I term as drone corpus. So the drone corpus can include all these drone manuals, maintenance record, mission logs, pilot reports, voice communication, etc. AI. So AI is the most, I say in most of the conferences, in most of the talks, AI is a very misused word. Misused in the sense, AI हम कहीं पर भी लगा देते हैं. AI is without realizing what goes behind that AI, where will that data come from? So there is something known as, again, this is research work is on tabula rasa, T-A-B-U-L-A-R-A-S-A, tabula rasa AI. Now this is a blank slate. It does not need data. It will be a trained model, but without data. So you have to think on these lines of what exactly the future will be in 2047. If we are preparing for 2047 with the threats of today, I think we'll be looking for 2074 in 2047. Then golems. generative large language multimodal models. Again, we have just not to be confined with our GPTs and LLMs today, what we are happy with. We have to move ahead. Golems, what are they doing?
Anupam, you'll have to
Sir,
close.
I'll just close up with the quote that the illiterate of the 21st century will not be the one who cannot read and write, but those who cannot learn, unlearn, and relearn. So this is most important, and we have to go as a state full throttle, and full throttle in the sense, full throttle not just in one domain, but in every domain that we see technically related to this. With this, I close as per the directions. Thank you so much.